a hexacoordinate cobalt 3 whose modality is given, TF is given, KF is given. He has asked me to calculate what will be the number of chlorine atom in the coordination sphere. So this is simply TF is equal to I into KF into molality. So if you calculate, I is coming out to be 3. This is only possible if your complex is CONH3 whole 5 Cl and Cl2. Then only you get I is equal to 3. So your answer is Y is equal to 1. Next, delta G0 of this reaction is given. Now this entire energy is utilized to oxidize M into M plus 3, M plus to M plus 3. E naught is given. Now he has asked me to calculate in this process what will be the total number of moles M plus that will be involved. So this is, I can simply relate one thing, that 193, that is into 10 to the power 3, that joule, that should be equal to N into E into F. That is N, E is 0.25 and F is 96500. If you solve it, N becomes 8. Now, 2 moles of electron is associated with 1 mole, therefore 8 moles of electron is associated with 4 moles. So the answer is 4. For the octahedral complex of iron, both in the plus 3 state, in one case you have SCN ligand and other case you have CN ligand. Now he has asked me to calculate difference in the spin magnetic moment in the two cases. Now since this is the weaker ligand, here the spin magnetic moment is coming out to be 35, which is roughly equal to 6. And here the spin magnetic moment is coming out to be 3. Because of the compression of the electrons, you will have only one unpaired electron. So n into n plus 2 square root, that becomes 3, and that is roughly equal to 2. So the difference is 4. And that's the answer. In a structure of N2O3, he has asked me to calculate what will be the total number of unpaired electrons. So if you look at the structures, the total number of unpaired electrons is 1, 2, 3, 4, 5, 6, 7, 8. So the total number of unpaired electrons is 8. Therefore, the answer is 8. Out of this compounds and species, now he has asked me to calculate, find out the numbers that have linear and without involving d orbital in the hybridization state. So these 4 are linear molecule without involving any d orbital. They are also linear, but they have involved d orbital in the state of hybridization. So the correct answer is 4. He has asked me to calculate the degeneracy of second excited state of H-. For a multi-electron system like H-, energy depends on 2 quantum numbers, both on n and f. Keeping that thing in view, the first excited state in this case will be 2s. And the second excited state, that is this one, will be equal to 2p. That has 3 orientation. So clearly the answer is 3. The number of stereoisomers that this compound N can have. We can simply say any compound has only one mirror image. So it will have its own mirror image. So the total answer will be 2. The number of resonance structure this compound N can have. So we can simply say that with NaOH we are going to get one structure. There will be abstraction of acidic hydrogen. This. So we can draw different structures, like I can write one structures, canonical structures, this one. Similarly, I can write another canonical structures. So I can carry out the process in this ring. I can carry out the same thing in the left ring also. So total number of such structures is 9. So now this is the structure that was treated with NaNO2 and HCl. Now the correct answer would be CH3, CH3, now in fact there will be retention of configuration due to neighboring group effect. Now C is the correct option. Now again he has given 4 statement regarding purification of copper. And we have to find out the correct statement out of 4. The first statement is impure copper strip is used as cathode, which is wrong. In fact, it is pure copper is deposited as cathode. So first statement is wrong. Statement B, acidified aqueous CuSO4 is used as electrolyte is the correct statement. So B is the correct statement. Pure CO deposit at cathode, as I have already said. So that's a correct statement. C is also correct statement. Impurity settles at anode bond, and this is also a correct statement. So the correct answer is B, C and D. Now here there is a question. Fe+3 is reduced by hydrogen peroxide in alkaline medium, hydrogen peroxide in aqueous medium, hydrogen peroxide in acidic medium. The correct answer is, in alkaline medium, hydrogen peroxide reacts with Fe+3 and converts it to Fe+2. So, A is the correct statement. B is also correct because the Na2O2 with water will give you H2O2 together with alkali NaOH. So both A and B are the correct answer. Now here is a graph relating percentage yield of ammonia with time. The reaction is exothermic in nature. Now the question is, if the reaction is carried out at higher temperature, then what would be the nature of the graph? At higher temperature, rate will be faster, but since the reaction is exothermic, the percentage yield will be less. So this will be the nature of the graph T2. So the correct answer is, and as per the choice, B. Now in a FCC unit cell which is made of oxygen, now according to the question, M fraction of the octahedral hole is occupied by aluminium and N fraction of the tetrahedral hole is occupied by magnesium. Now if I calculate the charge, oxygen has -8 charge, so aluminium must be 2 so that you get +6, and magnesium must be 1 so that you get +2, so the net charge becomes equal. Now if octahedral hole, aluminium has octahedral hole, now there are 4 octahedral holes in which 2 aluminium is there. So half fraction is there. Now there are 8 tetrahedral holes in which only 1 is occupied. So this is 1 by 8. So the correct option is A. Compound which on hydrogenation will give you optically inactive compound. Now these are the two, B and D. This on hydrogenation will give you a compound that has plane of symmetry. So the correct option is B and D. Now, what product you are going to get? If you look at it, this is a case of classical Aldol reaction. Acidic hydrogen will be abstracted from this. Now there will be Aldol reaction followed by elimination. So the product is A. Should be there at the end product. Well, this compound is treated with 1 equivalent of HBr. Which one will be the major product? Now, definitely this cation will form. Now there is chances of formation of this. Now this is 1,2 addition and this is 1,4 addition. Now since he has not mentioned anything about temperature, let us assume the temperature is the room temperature. Then it is the 1,4 addition, that is the major product. Now this with Br minus will give you this. Now according to this, your answer is D. Structure of D class glucose is given. He has asked us to find out what will be the structure of L minus glucose. So this is nothing but its mirror image. Its mirror image, which is found coming up to be A. Yes, column matching. Now carbonate. So what is siderite is FeCO3, malachite is CuCO3 and calamine is ZnCO3. So this is PQS. Sulfide, if you look at it, the entire thing, there is only one sulfide, that is argentite, Ag2S. So this is T. Then come hydroxides. Hydroxide is malachite one hydroxide and bauxite is another hydroxide. So the correct answer is QR. Oxide, there is only one oxide and that is bauxite. So this is R. Now the second column matching, freezing of water at 273 Kelvin and 1 atmosphere. So freezing of water, if we have said, we can simply say, okay, delta S, the system must be less than 0 because this is a freezing process, and this is a phase transfer process, so it is in equilibrium, so delta G is also 0. So I can say R and T as the correct matching. Second, expansion of 1 mole of an ideal gas into a vacuum under isolated pressure. If it is in vacuum, W is equal to 0, Q isolated, so Q is also equal to 0, and hence delta U is also equal to 0. So the correct answer is PQS. And the third one, mixing of equal volume of two ideal gases at constant temperature and pressure in an isolated content. If there is a constant temperature and pressure, we can say delta U is equal to 0, Q is also equal to 0, hence W is also equal to 0. So again, this is PQS. The last one, reversible heating of hydrogen from 1 atmosphere to 600 atmosphere, again reversibly cooling to the original place, original state. We can simply say all functions like delta U, delta G will be equal to 0. So S and T are the correct option. Q is also equal to 0 and work done is also equal to 0 because its area covered by the circular path is nil. So P, Q, S and T. This is the